Hello everybody, my name is Ali from University Technology of Malaysia. Today we want to show you how to use the CA Linux and especially Salome and Code software. I select the application CA Linux and Salome and Code. After running the terminal, you can start working with the Salome and Code. First of all, you have to make a geometry, and I press the geometry button and make a new geometry. For this case, you can import a geometry from the other software, but I want to make a geometry in the Salome environment. At the first step, you have to define some points, and after that we can connect this point with some lines and curves, and then you can make a volume and a geometry. Okay, our first point is equal to 0, 0, 0, and it means we make our geometry in the origin. And the second one is equal to 0, 0, and minus 50, and I press the apply. And the third one is equal to 20 and 70. The fourth is equal to minus 20 and 70. Press the apply. And the fifth one is equal to 0 and 90. Press the apply. The sixth one is equal to 50 and 0. Press the apply. And the seventh is equal to minus 50 and 0, and then press the apply. The 8th is equal to 0 and 30 and 35. Press the apply. And the last one is equal to minus 30 and 35. And you can press the apply and close button, and you can change the view into the front view, and you can see all the point is created. Okay, at the moment we have to make a arc and two curve and connect this curve and arc with each other. The first arc is the lower arc, and we have to select this point, and after the selection you can see the arc is appeared, and you can press the apply and close. And I press the apply, and I continue my progress into the next arc. The first point should be here, the second one here, and the last one is to be here, and the arc is appeared. And after that I press the apply and close. Okay, we have to make two arcs. To do this work, we have to press the shift button and press our appropriate point, and we can active the preview command and use the interpolate function, and I select again, and you can see our curve is very smoother than the other one. And I press the apply and close, and I make another curve here. Select the shift button and make your geometry, and you can see we have a continuous line. Okay, at this time we have to make a face with using the build menu, and select the build a face. We select all arc and curve which we created in the last item by selecting into the 3 command, and after that I press the apply and close, and we make a new face. Okay, we have to define the other point to make some another circle. The other point is equal to 20, and the z direction is equal to 0, and I press the apply. The other one is equal to 0 and 70, and I press the apply and close button. Okay, at the moment we have to make some circle. But before this we have to make some normal vector, and we have to select an OX vector into normal this circle into the OX, and we can change the radius of this circle into 9mm, and then I press the apply and close apply, and the other circle should be at the origin, and you can see the center point by default is to be at the origin. Okay, and the radius is equal to 10mm, and then I press the apply, and the last circle should be here by normalize to the OX vector, and the radius is equal to 6mm, and then I press the apply and close. Okay, we have to make 2 face. The first face is include these 2 circle. By press the control button, I select these 2 circle, and I make a new face, and then I press the apply and close, and we have to make 6 circle around this by using this circle. And for this work we have to select the multi-rotation, and our main object is this circle, and it should be create around the main axis, and our vector should be normal to the OX, and the number of this circle should be to 6, and you can see the preview of this circle, and then you can press the apply and close button. Okay, we have to make another face. In this time I go to new entity, build menu, and create a face. I select okay, sorry, before this I have to make a face, and then we can make a new rotation. I select this circle, apply and close, and at the moment I can repeat this phase 6 times, OX and 6 times. You can see here, apply and close. Okay, at this time we have to subtract the created phase from the main phase. At this time we use the cut from the operation and boolean menu. The main object is the phase 1 and the tool object is the multi-rotation, and then I press the apply and close, and the next job is the cutting the phase 2 from the cut 1. The main object should be cut 1 and the tool object is the phase number 2. Here, and apply and close. Okay, at this time I hide all the item except cut 2, and if I change the display mode into the shading, you can see we make our appropriate face in this environment. Okay, at this time I have to extrude this face along OX vector. I select the construction by extrusion, and the base is the cut number 2 and the vector is the OX, and the height of this should be equal to 50 millimeter. And you can see the preview and then apply and close. If you change the display mode into the shading, you can see the final shape of this component, but we have to subtract another volume from the created component, and to do this we have to define another point. Before this I have to change our display mode into the wireframe, and then I have to define length unit into the millimeter. Okay, the other point, it should be here, 10 minus 60 and minus 60. Look at this here. The other one should be 30 minus 60 and minus 60, the lower line, and I change it into the 10 minus 60 and 85. You can see here, apply, and the other one is equal to 30 minus 60 and 85, and then I press the apply and close button. I have to make a extrusion. To make extrusion I have to make line and then transform this line into the face, and then I have to create an extrusion, and to do this you can see whatever I do. I select this point and this point, you can see the line is appeared. Then I select another point, and then another one, and then the last one. and I press the apply and close. Then I select the make a face, and I select this line with each other, and then I press the apply and close. Okay, at this time I have to make a geometry, and our geometry at the base should be equal to the face 4, and the normal vector is equal to the OY vector, and the height should be over than the width of our component. I define it is too much. 150 is okay. Okay, at this time I have to subtract these components from each other, and to do this I select the cut, and then I cut the cut number 2 from extrusion 2. Sorry, I had to cut extrusion 3 from extrusion 2. The main object and the corresponding. You can see this. Okay, if I turn off all of the option and hide all, and then okay, after making the geometry, we have to make a boundary condition, and then we can make a mesh, and then we can analyze in a statical condition. Okay, first of all, I active the geometry, and I open the study 1, and I turn on the last step. You can see here, and you can see in the shading mode, and by using the rotate command you can see all aspects of your component. Okay, before making the grouping for boundary condition, we have to make a fuse to integrate all the part of integration, all part of the component into a integrate component. By using the fuse command, we integrate all aspect of this component, for example face, point and line with each other, and after applying close we have a wholly component. Okay, at this time we have to make a boundary condition. The first boundary condition is related to the top hole for a fixed condition, and then we have to apply some load in the main shaft axis, and after that we can make a analysis. Okay, I have to go to the new entity group and create a group. The main shape is the fuse number 1, and I choose the face, and I change the view into the wireframe mode, and you can see I select this face and this face, and I press the add button, and I change the name of this group with a fix holds, and I press the apply button. The second group is the loading area, and this is related to this face and this face, and I press the apply and close. Well, you can see just the boundary condition, the fixed point and the loading, and then we can go to the mesh environment, to the making a mesh. Okay, in this case I select the create a mesh command from here or from the mesh menu here, and I choose the last one, the fuse number 1, and I assign a set of hypotheses in a 3D automatic tetrahedralizing mesh. And in this case, let us to make a set of mesh. For example, we choose a particular mesh for 3D and a specific mesh for face or line. In this case, the default of program is the maximum size of mesh, and if we want to high accuracy, we have to reduce the amount of the length of mesh, and I reduce it into 3, and I press the apply and close, and after that I press the compute. The program is going to progress all the mesh node and the volume of our component. Okay, if we make a little mesh, it may take several minutes to calculate all the mesh. As you can see, the number of nodes is more than 90,000 nodes, and you can see all the information of our mesh here. And I close this windows, and you can see we have a set of mesh here, and after this we can make a analysis by using the Aster environment. And to analyze our component, I select the Aster from here, and we change our module into the Aster. Okay, by using the Aster menu and using the wizard, we have 3 options: linear elastic, model analysis, and linear thermic. In this case, we want to analyze in a linear elastic, and I select this item, and because of the shape of our geometry, I select the 3D. So we can select the plane stress, plane strain, and axis symmetric in the 2D two-dimensional component. However, our component is three-dimensional, and I selected three-dimensional, and then I press the next button, and then I have to select a mesh for this case, and I select the mesh number 1 and here, and then I press the next button, and the type of our component is aluminum, and the Young modulus is equal to 70 gigapascal, and I defined it, and the Poisson ratio is equal to 0.3, and I press the next, and as you can see, the first group is the fixed hole, and the degree of freedom in the other direction is equal to 0, and we accept it. And then we press the next one, and the loading area, we want to apply 10 kilopascal in the hole, and we type 10,000, and it means it is equal to 10,000 pascal or 10 kilopascal, and I press the next button. At the moment I have to save our result into a new name, and I choose the name as a pulley, and I save it, and finally I press the finish button. You can see we have the Aster module here, and I minimize all of this, and we have linear elastic here. At this time I run the linear elastic, and you can see the progress of the solving. Okay. You can see the progress of the result, and the result is here. You can see all the text of result, here, and then you can go to the post-pro environment, and you can see the final result. Okay, after running the Aster code, we can see the post-pro environment is activated. We can go to the post-pro environment and go to the field menu, and we can see three types of results. The first one is related to the total deformation. The second one is related to the tension and the stress around our component, and the third one is related to the dimensionless deformation and displacement. Okay, for the first one, I activate the deform shape, and I activate the magnitude coloring, and then I press apply and close it. Let's see here, and this is our component. And if you want to change the display into the surface from the wireframe, I change it, and we can see the total deformation around our component. The second one is related to the scalar map, and I choose the funimized stress, and I activate the vertical following here, and it is an overlap between the deformation and scalar. I just want to see the result of the stress, and I activate the show only, and you can see the maximum stress and stress concentration is around the main for the shaft. And this third one is related to deform shape and scalar map, and I choose it, and this is the scalar map factor, and I activate it, and you can see the final result by showing. Okay, sometimes you need to see your result very bigger than the normal, and you can use the clipping plane by choosing a plane in XY direction, and you can change the place of this plane, you can cut, and then you can see the result. Yeah. Delete it, and change back to the first